Okay, this is our review for the second review for our final exam. This is the chapter dealing with quadratics, or parabolas. The first question says, graph the function, identify the vertex and axis of symmetry. So you may have to go back and look in your notes, but we had an equation x equals the opposite of b divided by 2a. That's how we find the axis of symmetry, and it's how we find the x-coordinate of our vertex. So for this particular problem, we want to identify a, which is the 1 that's in front of x squared, b is the 2 that's in front of x, and c equals the constant 1. All right, plugging them into our equation, we want the opposite of b. So if b is 2, we're going to take the opposite, or negative 2, and then on the bottom of our fraction, we're dividing by 2 times a. A is 1, so we're going to do negative 2 times, or divided by 2, and we get a negative 1. So our axis of symmetry is x equals negative 1. That's also the first coordinate, or the x-coordinate of my vertex. And the way we find the y-coordinate is we plug that negative 1 back into our equation. So we have negative 1 squared plus 2 times negative 1 plus 1. Simplifying, negative 1 squared is 1. 2 times negative 1 is negative 2. We have 1 plus negative 2, that's negative 1, plus 1 is 0. That's what goes back here. So we have a vertex at negative 1, 0. Okay. We have an axis of symmetry right through there. And if we go back and analyze our equation, since this is a positive 1 here, positive 1x squared, the parabola should open up. So we know that our graph is going to curve up from there. And then we have to just find a few other points. So we start with our vertex in the middle. We've had the negative 1, 0 as our vertex. And then we combine, or we add the x's up going by 1, so we have 0 and 1. Going down, we have negative 2 and negative 3. And then remember, because of symmetry, those two answers should be the same, and these two answers should be the same. So if we put a 0 into our equation, x squared or 0 squared would be 0. 2 times 0 is 0. So the only thing we have left is a 1. And again, because of symmetry, we're going to have a 1 there. If we put a 1 into our equation, we're going to go back and change these to positive 1s. We still have a 1 here. This becomes a positive 2. We end up with a total of 4. And again, because of symmetry, we're going to get a 4 there as well. So plotting those points, 0, 1, 1, 4, negative 2, 1, and negative 3, 4. All right, and then we're going to draw the parabola in. All right, second question. Since the height of a thrown ball is given by this function, how long does it take the ball to reach its maximum height, and what is the ball's maximum height? These questions right here basically just say find the vertex. Okay? If we have a ball and time is on our x-axis and we're looking at the height on the y-axis, the ball is going to go up in the air, and then because of gravity, it's going to come back down. We're looking for this. How long does it take us to get to that highest point, and how high does it get? All right, so we're really just finding the vertex. So we need x equals the opposite of b over 2a. In this case, b is 24, so we need the opposite, or negative 24. On the bottom, we have 2 times a, and a is the negative 16. Simplifying, we have negative 24 divided by negative 32. Grab your calculators, punching that in or reducing the fraction, we get 3/4 or 0.75 seconds. So it's going to take 0.75 or 3/4 of a second to reach its highest point. To find the highest point, that's our y-coordinate. So we just need to figure out our y value when x is 0.75. So h equals negative 16. Our time is 0.75 squared plus 24 times 0.75 plus 10. So we're just substituting that 0.75 back in for time. Again, grabbing your calculator, we end up with a height of 19 feet. Okay? All right, question 3. To solve the following using square roots. In order to square root, we need to get the x squared all by itself. So the first thing I'm going to do is add the 81 over. That gives me x squared being a positive 81. Then I can square root both sides. And remember, when we square root, we have to include a positive and a negative root. So we end up with x being positive and negative 9. Question 5 here. We have 2 things to do before we can square root. First thing is to add the 147 over. Second step would be to divide out the 3. And then the last step would be to take the square root. Again, I need plus and minus. So I end up with x equaling positive and negative 7. All right, question 4. It says, which equation most likely matches this graph? A couple things to look at. 2 of your functions down here are positive for your a term, and 2 of them are negative. Right? And if our graph opens down like that, kind of like a frown, then we know it has to be one of these. Okay? To narrow it down further, let's try finding which equation would have that point. The coordinates are 0, 0. Well, if I plug 0, 0 into this one, if I put that x in here, 0 squared is 0, 0 times anything is 0. That's what gets me a y-coordinate of 0. So it would have to be b here. Okay? This one has that extra plus 3, which would take our parabola and shift it 3 units higher. So that one is not going to match. All right, the last part deals with solving quadratics. The first part was all graphing and finding vertex. This is dealing with solving the quadratics. We have a couple different options. The first one is the zero product property. That's where we have it factored, and in this case, it's already factored. In this one, we're going to have to factor first. So once you have it factored, you're going to take each factor and set it equal to 0. The zero product property says that if one of those is 0, the whole thing ends up being 0. So to solve this, we would add 1. That means 2x has to equal a 1. Then we could divide out the 2 and get x being 1/2. For this one, to solve for x, we would have to subtract a 7. So we end up with x being a positive 7. We get 2 solutions, 1 for each factor. Question 7 is expecting you to factor it first. And remember that before we can factor, we must have one side equal to 0. All right, so we're going to have to bring this 18 back over to the other side. We cannot combine it with 3x because it doesn't have an x on it, but we can put it over on the same side. And now question 7 looks just like question 6, where we can factor it. All right, so we're looking for 2 numbers that multiply to be negative 18. So my options would be negative 1 and 18, or the opposite 1 and negative 18. I could use negative 3 and 6, 3 and negative 6. I could use 2 and negative 9, negative 2, positive 9. The only one that's going to get me a positive 3 when I add them up is this one. So I need x minus 3 and x plus 6. Then I solve each of these, setting them equal to 0. I can add the 3 over. So x equals 3 is one solution. And I can subtract the 6 over. So x equaling 6 is my other solution. All right. The last type of solving that we did was with the quadratic formula. That was that big, long x equals the opposite of b plus minus the square root of b squared minus 4 times a times c, all of it divided by 2a. So the first thing you want to look for is make sure you have one side equal to 0, which we do. Second thing you want to do is identify what are your a, b's, and c's. So in this case, a is 1. That's the number in front of x squared. B is the number in front of x, which is negative 4. And c is your constant, which is positive 3. Then it's just a matter of plugging them into our equation. We need the opposite of negative 4. So we need positive 4 plus minus the square root. We need to take b, which is negative 4, and square it. Then we need to subtract the product of 4 times a, which is 1, times c, which is 3. And then the last step, we need to divide it all by 2 times a. Simplifying. We have 4 plus minus the big square root symbol. On the bottom, we have 2 times 1 or 2. Inside that square root, the first thing we have to do is take the negative 4 and square it, which gives us a positive 16. We are then subtracting the quantity 4 times 1 times 3, which is 12, and 16 minus 12 is 4. So x equals 4 plus minus the square root of 4 divided by 2, which is 4 plus minus 2. If we square root that 4, we just get a plain 2 divided by 2. And then we have to go through and do 1 with the plus sign and 1 with the minus sign. So 4 plus 2 divided by 2, and 4 minus 2 divided by 2. This gives me 6 divided by 2, which is 3. This gives me 2 divided by 2, which is 1. So I have two solutions. X could equal 3 and x can equal 1. And the last one in our review today, again, identifying a, b, and c. I'll put them over here. A equals 2, b equals negative 2, and c equals negative 3. All right, so x equals the opposite of b, so positive 2, plus minus the square root, b, negative 2 squared, minus 4 times a, which is 2, times c, which is negative 3. All divided by 2 times a, which is 2. Simplifying, we have 2 plus minus a big square root, all over 4. Inside that square root, negative 2 squared is 4. We are subtracting 4 times 2, that's 8, times negative 3 is negative 24. And subtracting a negative is actually the same as adding. So we end up with the square root of 28. So x equals 2 plus minus the square root of 28, all divided by 4. Now if it comes out like that, where it's not a nice perfect square, go ahead and grab your calculators. We're going to take 2 plus the square root of 28, get that answer, and then divide it by 4. That should come out to be about 1.8. And excuse me, the other one, x equals 2 minus the square root of 28. Get that total on your calculator, and then divide by 4, and we end up with x being about negative 0.8. Okay? Make sure you keep these notes out to use as you're working through your review worksheet number 2.